Thank you, Dr. Swamy. This topic, Industry 4.0, the quality imperative, this struck me about 2 weeks ago because in our country, we hear words like nowadays, Make in India, Atmanirbhar Bharat. India aspires to become a global manufacturing hub, competing with China and several other countries. This is the kind of buzz we hear. But I hardly heard manufacturing being talked about a lot. But what about the quality of what we are manufacturing? How world class is our manufacture, whatever we manufacture in our country. Are we best in class? Can we be talked about the same way like a German Mahom milling machine? It's a machine tool coming from Germany, a high precision machine tool, and they are world famous, the Maho company. Are we talked about in the same language about our machine tools, about our manufacture, about our products, and about our services? When I talk about manufacturing, I'm also including both products as well as services. Okay. Manufactured and delivered by India. So that's what is about Make in India. And I have not heard either in the government circles or most of the private forums, quality being talked about a lot. Why I am talking about the quality imperative when we talk about Industry 4.0? Let me just give the background before I open up the presentation. When we see the evolution of the industry right from 18th century to the 21st century now, Industry 1.0 was about moving from cottage industry to an organization-based production of goods and services. That happened in the time period 1750 till around 1890 or so. At the dawn of the 20th century, around 1900, we talk about that as Industry 2.0. What's the major difference between 1 and 2? In Industry 1.0, it was mostly steam and water were mainly used as power sources for running machines by individuals. Steam and water. By the time we came to Industry 2.0 in the early 20th century, electricity, by the time it was the 20th century, electricity being generated, distributed, and being used for industrial machine power sources that has come into vogue, and mass production of goods and services began. And that was Industry 2.0. By 1960s, the electronic industry made huge impact. The integrated chips, the transistors, all the electronic devices being manufactured brought in Industry 3.0 around 1960s onwards till around 1990s. And the dawn of the 21st century, we now talk about Industry 4.0. What's the major difference between 1, 2, 3, and 4? If you look at Industry 4.0, currently, which is on, it's more about IoT, the Internet of Things. It's about machines talking to machines. It's about SCADA systems. It's about control of machines through data acquisition, through sensors and others, and then you run your equipment. And men talking to machines has come down a lot. In IO 3.0, at least a lot of work of the skill of the man got transferred to the machine. And that's why we had in IO 3.0 mostly numerically controlled machines, computer numerically controlled machines, etc., where the skill of the man got transferred to the machine. Whereas IO 2.0, which was from the 1900 to around 1960s, it was all about employing more men, build up capacities, mass produce things, and make them easier for access and usage, and the cost of production, marginal cost of producing a component being brought down. That was the whole theme during IO 2.0, where motion study, work study, methods, and management of organizations, even the management philosophy grew in Industry 2.0. When it comes to Industry 4.0, all this has now become totally in the cyberspace, and it's about communications technologies. It's about very little involvement of men, but everything being done by robots and machinery. And it's the days of artificial things, artificial intelligence. It's the days of machine learning. It's the days of pattern recognitions, and then doing a 3D printing technology being used to design, manufacture, and called additive manufacture. I mean, these are the kinds of words we seem to hear now. So this is the progression that has happened from the 1730s to the current 21st century. Okay, I would like to walk through you this through one particular slide and then emphasize what kind of changes have taken place in terms of the quality that evolved over the same time period. There were huge monuments constructed in India, for example, Taj Mahal, much earlier than even 1750s, when steam and water were being used as power sources. How did they do all that? And Taj Mahal is one wonder of the world. All done by men at work and using very simple tools, hand tools. They didn't have machinery, using electricity as a power source to do things for them. Just imagine, the quality those days was all about individual passion for perfection. If any of you have traveled to Belur and Halibet temples in Karnataka, you would marvel at the intricate sculpture that you see on stone being carved. What kind of tools had they used? They were not using any carbide tipped, stainless steel tools which are used in manufacture, or titanium tools, etc. But the quality used to be very good. The quality, the output quality, which goes to satisfy a customer's need. We will get into all these details. From that quality 1.0 was about individual passion to achieve perfection, and all handmade tools by men. When it came to quality 2.0, when Industry 2.0 started and mass manufacture started in the early 1900s, in the 20th century, you found that a lot of quality control tools were used, but it mostly downstream quality control. That means you make the product first and test the product whether it satisfies the requirement. Inspection and testing were in vogue, but after the product was manufactured. It was always a post-mortem to check, to inspect whether something is a go or a no-go using instruments. That's how metrology tools and measuring instruments, they all developed during Industry 2.0, which would be called Quality 2.0. Quality 3.0, Quality 2.0 also started with a lot of techniques being used, quality control techniques being used, mostly using statistics, probability theories on and sampling of mass-produced items. You can't test, you can't inspect all the items that are being manufactured when they are being manufactured in their thousands and lakhs and millions. So you sample, inspect, and test, and apply whatever outcome you get out of sampling, inspection, or testing to the entire population of the lot of production. So a number of statistical quality control techniques, statistical process control techniques, they all were used as part of Quality 2.0. When it came to the 1970s and when the Industry 3.0 started, the quality evolved more from downstream quality control after the product is made to upstream quality control. That is about you design your entire process of manufacture of your products. All the processes that you are using for the manufacture of products, it's about designing those processes to build in quality into whatever process you are working on. After all, a product quality is as good as the process by which the product is being made. Therefore, the focus in the 1970s and later was on totally process quality controls and upstream quality control at the design stage. Ensure, so you are assuring quality is being built into your product. You are not doing inspection or testing. So from quality control, you move to quality assurance, and you started giving warranties for your products and services, that my product will not give you any problem for the next 10 years. Like for washing machines, these days warranties are given for 5 years, 10 years, because they are so sure of the quality of the products. So quality has moved to talking about reliability, that is quality over a time period also. So that is the kind of movement that has happened in Q 3.0. Now, when it comes to Q 4.0, what will that be? Currently, what are the kind of quality practices that are being followed? As the industry evolved from 3.0 to 4.0, with all the latest cyber and cutting edge technologies that are being used and cyberspace being used to communicate and control devices which manufacture products and services, where entire automobile factories are completely using robots to manufacture. I understand there's a company in Japan where the CEO and the security are the two individuals work there. The rest are done by robots in the entire factory. Only 2 employees. These are such days. So, dear friends, as much we talk about the manufacturing part of the industry revolution and industry 4.0, let us also think of what kind of quality needs that will be there, because without the quality being supreme, without quality being built into the products and services that we render, not only within the country, but when we want to export to other countries, and if India aspires to become a global manufacturing hub, it definitely needs to look at what kind of quality are we building into our products and services. What I'm going to cover in the next 45 minutes or so are some of the tools and techniques that the quality departments and quality management systems of organizations use to keep pace with the developments in manufacturing and technologies. Okay, what kind of new tools and techniques are being used? Yeah. Give me just a minute. I'll open the presentation. Here we go. This I can. Yeah. This was what I briefly talked about. This is how the manufacturing evolved from 1.0 to the current 4.0. How long it will last before we reach industry 5.0 is in the speculative domain, but this is how it happened. I briefly mentioned about this. From 1.0 to 2.0, it is about machines which had water and steam as power sources in 1.0. In 2.0, they were all run by electricity, and machines became portable because machines themselves had their own power sources to be plugged into a electricity power location. And 3.0 is more about invention of electronic devices, automation, NC, CNC machines, computer software, okay, integrated systems where machines, the data from one file of one system can move to another file of another system. All these integrations and ERP systems, enterprise-wide resources planning systems, customer relationship management packages, supply chain management, all this grew in 3.0 because outsourcing also took share of manufacturing elsewhere rather than you own your own manufacture. Parts being made in some other country, you do assemble, test it, and sell your products. This is the kind of outsourcing of various parts and components and sub-assemblies. All these have started happening in 3.0. If you look at one example of 3.0, Boeing company manufactures Boeing passenger aircrafts. Approximately 3 lakh individual components and systems and sub-assemblies go into manufacture of one Boeing 737 or 747 aircraft. You can imagine how huge will be the supply chain for them, which is spreading across the globe, and how the PPC functions, how the production planning and control happens in Boeing company. You know, that's about supply chain management, which took deep roots now. So from that, we moved over to 4.0. In 3.0, individual machines still worked on individual components, parts, etc. Whereas when it came to 4.0, now the machines interface with other machines. The data from one output of one stage in a manufacturing shop, suppose you have a production shop with about a battery of 20 CNC machines integrated with each other, the components being made in some of those machines, some components being made in one machine, moving over to another machine, etc. All this happen in a highly optimized manner nowadays. And each machining center will have multi-tool capability, 612, 10 turret, tool capacity, 16, 20, 30. I mean, you can imagine in one machining center, how many operations can be done. In 3.0, it was mostly about individual machines with the limited capability to carry multiple tools. Whereas in 4.0, when you start using robots for even painting an automobile nowadays, okay, everything is controlled through machines. And the machine systems integrate with other machines. And that's how the coinage of the term IoT, Internet of Things. Okay, so this is the evolution. I am focused on what is about the quality part. In 1.0, it was self-inspection, checks, and a passion for inspection. Individuals checking their own work. A sculptor checks his own work. A carpenter checks his own work. A welder checks his own work and they certify. And 2.0, it's more about one department manufactures, another department inspects and tests independently. Downstream quality inspection, product testing, statistical quality control, sampling, and metrology tools being used, and statistical process controls being applied, the rule of seven principle being applied for mass manufacture of parts, just to check whether the variation in the dimensions or the attributes that you want to measure, the variables that you want to measure in a process, whether their variation is within limits or beyond limits. If it is within limits, then there will be a limit. There is a tolerance band for every component dimension to be manufactured. And then if you are within the tolerance band, it passes. If you are going beyond the tolerance band, the part fails. Then you stop the machine. That's what would have happened. That's what were happening in 3.0, where the machines themselves used to check whether they are out of control. And condition monitoring of machines and others used to happen in Industry 3.0, where the checking part, the measurement part, the metrology tool part is embedded within the machine itself. In CNC machines and others, no individual checks. The graph gets displayed of the component under manufacture, real time, and then you continuously keep checking whether it's under control or not. If it is beyond control, there will be an alarm given by the machine. The machine itself stops. There will be interlocks built into them because you are controlling everything through electronics, through integrated chips. And that's what was the revolution in the 1970s that happened. When it came to 4.0, Industry 4.0, similarly, the quality part there. Now, condition monitoring of machines continuously and real-time self-diagnosis of a tool being used, of a raw material being used, of a machine, its process capability. Process capability of a machine deteriorates with time. So you continuously monitor the process capability of the machine. Process capability here, just by definition, is the allowed deviation, that is the design deviation allowed, divided by the actual deviation being measured during manufacture. If the allowed deviation by actual deviation, if the ratio is 2.5 or above, then the process capability is considered to be very high, very good. Most of the Japanese and German manufacturers in their processes aim at, through their design, aim at a process capability of more than 3.5 to 4. Okay, continuously they keep monitoring the capability of the process. And that's what we do in 4.0, because your product would be, the quality of your product would be as good as the process by which the product is being manufactured. So totally it is process controls, right from concept to commissioning of any product, throughout the processes stages through which the manufacture goes on, all those processes will have built-in quality checks. And that is nowadays called quality baked into every process. Now we call that quality being baked. Like when you bake biscuits or use bread to make some bakery products, you need to control the temperature, the time, and the composition of the materials that you are using, and through various processes that you follow. So you need to control all these parameters. And that's what nowadays in quality checks that happens. That's what happens nowadays in quality checking. There is no individual testing or inspection. Testing will still be there of a product before. It's called acceptance testing. Testing for the purpose of ensuring that it is meeting a customer's requirement, that is still being done. but all the in-process checks, inspections, manual inspections and others could be just a visual inspection. Rest of it is done through the process by the machines themselves. And if there is a defect, if there is a deviation from the specification beyond the control limits, the machine automatically will self-regulate, self-monitor, and self-control itself. And that is how machines getting interlocked when they work, so that there is a small variation at one stage gets corrected at another stage, if it is possible. If it is not possible, then at the other stage, there is an adjustment of the tool to ensure that you accommodate that variation. So lots of changes have occurred. Just to give you one example, recently I had been to an Aurangabad-based factory. They manufacture optical fiber cables. Okay, it's a Sterlite company manufacturing optical fiber cables. The telecom cables they manufacture fiber with optical fiber. And during the cable manufacture, the machines through which the cables are extruded, condition monitoring of that machines was happening directly from the supplier who is based out of US. If the operator sees an alarm, a display coming from the machine, which is numerically controlled, if the machine displays that something is wrong, it will also tell you, gives you the error code, what type of an error is happening, and the operator just stops the machine, informs the supplier, and the supplier from US actually through a video call, okay, will actually look at the picture, look at the error code, and then diagnose from US, and then it gets rectified. And lot of self-diagnosis tools are also built into satellite systems nowadays. You are aware of when the Chandrayaan-2 at the last stage, when it failed, okay, it failed because there was some defect, because some computational error occurred somewhere. We could not master that, and therefore it failed. And what they do is they will try to do a proper diagnosis of every element in the entire chain of the systems that make the Chandrayaan-2. They will go through it minutely, diagnose it, and then try to arrive at where something has failed. They will do what is also called FMEA analysis, failure mode effect analysis. Based on the effect, you go back to what could be the failure mode because of which this effect has occurred and what caused that failure. That kind of an analysis is also done. Those are done nowadays by the manufacturers themselves, not the customers of machine tools, not by the maintenance group. So maintenance has now become predictive maintenance, preventive maintenance, and condition monitoring of machinery, so that the process capability of the equipment that you are using is at a very, very high level. So nowadays, the concept of quality is now built into it, baked into the process, and therefore also called womb to tomb concept. The total life cycle of the machine or the tool that you are using to make components and parts, right from design of that machine tool till it is retired, it is scrapped. That's called womb to tomb concept. Okay. What I have put on this slide is, on the left side are India's aspirations. What I have earlier talked about, India wants to become a global manufacturing hub. Atmanirbhar Bharat needs, what are those needs? It needs high quality infrastructure, roads, ports, goods trains, to carry raw materials for the entire supply chain mechanism to be in place. Because of this COVID-19, because China is not able to now deliver to various other countries, several countries' supply chain mechanisms have been broken. This is the kind of impact nowadays we have, because globally we have become a village. So one area gets impacted, the rest of the world will see the repercussions. So those are the kinds of days where, therefore, we require high quality infrastructure when you want to become a global manufacturing hub. Roads, ports, goods trains, leveraging cutting edge technologies through skill upgradation, skill development of people. Just imagine, dear friends, how many of our MSMEs, micro, small, and medium enterprises in our country, what kind of quality control and testing they must be following. And we are planning to leap into Industry 4.0. I am aware of several MSMEs that I have visited during the course of my work, both in HAL and in Tata Consultancy Services. I had a passion for quality. So wherever I go, I used to check on what kind of quality systems are in place for those organizations. I did quality audits for organizations as part of a quality assessment for ISO 9000 certifications. I went to Glaxo Laboratories. Let me give you this example. You will all wonder. It's one of the best pharmaceutical manufacturing company in our country. And 3 years back, you know what happened? Suddenly, the Federal Drug Administration of USA, to whom 80% of the Glaxo Laboratories products were being exported, they asked the plants to be shut down because they are coming for testing, because they got a report from their federal inspectors who came on a visit to one of the Glaxo laboratories in somewhere near Pune. They found that in stores, raw material stores, chemical stores, they are not following good manufacturing practices. GMP they are called. Clean room facilities were not properly being maintained. They found foreign particles in raw materials that were stored in their stores department in one of their plants. Immediately the message went to all the 14 Glaxo laboratory manufacturing plants in our country. All of them were asked to be shut down by their own management because FDA disapproved. They said, stop all your shipments to us. Huge loss for Glaxo laboratory. Why? They could not sustain the quality requirements, specifications for the storage of raw materials in their premises. The same raw materials go into their finished products. And that is so serious. And their certifications were withdrawn. Their approvals were withdrawn till they rectified them. Enormous loss to Glaxo. Dear friends, this is one small example of what quality means in a manufacturing organization. Another example, may I share here, and that is about, you must all have known about what happened to Kalpana Chawla, the Indo-American space scientist who was on board one of the missions, and the entire mission, they got burned in the atmosphere, incinerated, just because the refractory lining, the heat shield of the space vehicle, they had some loose refractory bricks which fell off when the launch was happening from their space center. During the launch itself, they found a few of the refractory bricks falling down. Still, they continued with the mission. They took a huge risk, and that risk caused enormous loss. That's about the quality. What about the checks on the quality of the refractory lining of the heat shield of the space vehicle? Were they not done? They were done. They were done. They were done by specialists. But how did they miss the small? See, one small miss somewhere on quality can cost huge quality losses. They are called the cost of failure of quality. Quality costs of failures will be huge. And therefore, it's so important when we talk of India becoming a global manufacturing hub, an Atmanirbhar Bharat, a quality infrastructure being built, leveraging cutting edge technologies for manufacture and to achieve economies of scale. We are doing all this, but we also need to completely alter our own quality landscape during post-production of any manufactured item. So new age, high-end skills to survive in a highly competitive environment, they are all required nowadays. If we cannot deliver, if we cannot export to the requirements of the quality of a customer, quality by definition itself must conform to the requirements of the customer itself. I'll come to the definition of the ISO standards definition of quality in a few slides from now. But what I'm trying to convey here is the nations nowadays compete not about on their ability to manufacture, but their ability to deliver an assured quality product. That is where Germany and Japan, to some extent Italy, they are considered one of the best in the world. Their quality is considered one of the best in the world, even today. And India actually stands way low. And for success of Atmanirbhar Bharat, for the success of India to become a global manufacturing hub, it's our MSMEs, micro, small, and medium enterprises in our country, where there have to be a revolution in terms of the quality mindset of the employees working there. And that is the kind of alteration in the landscape, quality landscape, that will be required. That's what I have shown on the right-hand side of this particular slide. A manufacturing survival imperative nowadays, quality. That's why I called it the quality imperative. Like Germany, Japan, South Korea, Taiwan, etc. World class in product manufacturing and service standards also. Very high process capability in all processes from concept to commissioning. Design for quality, defect prevention, and error proofing, even during usage of the product. These have to be built into the product so that even if you by mistake operate something wrongly, it won't operate. Those are the kinds of days we are working. Okay. So quality management systems should be in place instead of engineering change notes. Engineering change notes are issued by the design and engineering departments of companies whenever they want to make a change to a particular component part of a product. It's called an engineering change note. And that change will be accepted subsequently. They have to make a change because they did not think of some implication, and therefore they make a change. Those engineering change notes are nowadays getting replaced by a highly designed quality management system, which will start operating right from your design, right from your product conceivement. That's why it is called concept to commissioning. So QMS in place of engineering change notes, a quality mindset change is required within every organization. So much we are talking about the quality imperative. What does quality mean? Simply it means, as per ISO 9000 2000 version, it is a degree to which a set of inherent characteristics, that is the features and characteristics of a product, fulfilling the requirements of a customer who placed an order for that product. The customer is paying for it. So the customer expects these features and characteristics. They are also called stated and implied needs, okay, of a customer. So those stated needs, which are called specifications, customer specifications, they have to be met. And also customer may not specify certain things. They will also have to be met. For example, if you are the manufacturer of a microwave oven, the customer will not tell you that you need to provide a handle to open the door of the microwave oven. And you need to provide a door handle which is sturdy, which cannot easily come off. No. These are necessary. So those are called implied needs. So stated needs and implied needs being fulfilled, okay, to a certain degree, to the degree to which the customer specifies, they have to fulfill. That's it. That is what is the definition for quality, whether it's a product, whether it's a service. Some very slang definitions of quality are also there, which are functionally, adequate, which are called, it must be fit for the use, for the purpose for which it is meant for. Quality is excellence that is better than a minimum standard, industry standard. Conformance to requirements, requirements being specified by the customer. The ability of the product to satisfy them is quality. So I told you it's about a total quality management system, and quality being baked into every process within a manufacturing organization which manufactures products, or an organization which is rendering services, like say a transport industry, like an airline industry, Indigo Airlines and others. They are also rendering services. There also, it's extremely important to maintain, to ensure that the quality management is built into your service. So I'm not differentiating between products and services. Look at some of the things when we use the term total quality management. Process thinking, training of the individuals who work on with machines, with tools. Effective communication, only facts being talked about, fact tables only being talked about, because in a QMS system, the entire management of a quality management system is by facts, is by data. And that's why in a industry 4.0, where data acquisition systems are used and data flows freely for machines to be interlocked and controlling the various processes, these SCADA systems play a very, very important role. The sensors which capture a temperature variable or a pressure variable or a time variable, etc., these things will have to be very accurate in what they communicate. Okay, everything is digitized in this digital world. So effective communication, fact-based decisions, integrated systems, continuous improvements to the quality happening, okay, which we call Kaizen, Japanese word, customer satisfaction, total employee commitment. The employee not only is trained, but the employee must be not only be able, the ability to get the job done in the right manner, not only the ability, but what about the willingness of the employee? That is the softer aspect of an employee working on a job. The ability is very high, but if the willingness is low, the quality of the product will still be average. Because the performance is a function of both ability and willingness to do the job. That means giving attention to the details of the work. Because that's why they say always the devil is always in the details. If there is any defect occurring in any process, you need to give attention to the details of the process. Total employee commitment, therefore, is a must. And teamwork and a quality chain, right from upstream to downstream, from the design stage till the packaging and delivery of a product. And strategic and systematic planning and control of quality. Just a few examples of what kind of tools and techniques that are being used nowadays. I can't talk about so many of them in 1 hour. Therefore, I just choose a few, but I'll just give you an overview of what is currently happening across the globe in terms of what kind of tools and techniques are being used. In large manufacturing units like GE, like Motorola, like even Indian manufacturing units like Hindustan Aeronautics or Bharat Heavy Electricals and others, they use they train people on green belt, black belt training. It's called Lean Six Sigma processes. Processes are being defined to ensure that not more than 3 parts in a million could be defects, could have defects. Okay, 3 parts in a million. That means 9,99,997 parts should be conforming to specifications. 3 in a million may not conform to specifications and may get rejected. That is the high process capability that you want to build into your processes. So there were Six Sigma quality movements that happened mostly in the 40s, 50s, 60s. One of the best examples is Motorola. They were pioneers in Lean Six Sigma applied to their IC chips manufacture. Okay. Nowadays, Lean Sigma principles are still being followed by a number of organizations. They are using a lot of statistical process control techniques, analysis of variance, and such other tools and techniques. Professor Taguchi's design of experiments is one such, etc. There are lots of techniques being used. I've just mentioned a few here. Real-time condition monitoring. The machine tests itself. I gave you the example of what happens in that optical fiber cable plant at Sterlite. That's real-time condition monitoring, because if the machine has some variability got introduced because of some cause, like fluctuations in the frequency of the alternating current of the electric source supply, or small vibration in the foundation of the machine, a small such cause could be enough for variability in your product. So they need to be aware of all these things and monitor them continuously. Real-time condition monitoring techniques of production machines is being done. Simulator-based training. Just for example, Indian Air Force pilots, when they fly the aircraft, when they are given training, ab initio training, their training is not given on actual aircraft because it is too costly a training. You may lose aircraft, you may lose people also during training. So most of the training is given on simulators. Now, those simulators, nowadays, how do you create that environment of a live environment for the Air Force pilot to feel that he is in an actual aircraft and then piloting the aircraft? That kind of an virtual reality, augmented reality technologies have been developed for you to be seen as if you are landing an aircraft and you will be operating all the equipment and control devices within the aircraft to ensure that you are landing properly. And the system will tell you whether you have landed roughly, whether you have had a smooth landing, and you get trained a number of times on such simulators. Similarly, in most of the equipment, augmented reality, virtual reality tools are being used for training, for testing, laboratory scale testing, etc., etc. So I'm talking about that. How to assure quality. Pokayoke. Pokayoke is about failure proof. Okay. How do you build in a fail-free equipment? It could be like these days, you must have heard of the term called maintenance-free batteries for life. You purchase a battery, you don't have to do anything with the battery, you use the battery, it has a shelf life, after that you have to just scrap it. Nothing needs to be done. Maintenance-free, fault-free, defect-free. So we nowadays only talk of design for zero defects. And Pokayoke in Japan, it's about failure proof. I'll just briefly explain as part of the explanation on that. I just have about 6 or 7 minutes. Let me run through this. SMED. SMED stands for single minute exchange of die. It's about how quickly through your process design, you can change the setup of a machinery which was till then manufacturing a particular component to switch over to some other component. The processing time might be very, very less, but normally in Industry 3.0, still the setup times used to be high. Now, in Industry 4.0, what happens is you still have to make it failure-proof, defect-free production, but you need to make the changes in the setup. So, single minute exchange of die principles removes one die and puts in a new die, and the whole time that it must take should not be more than a minute. That's just a principle, not that it will take only 1 minute, but the name got popular, called SMED. SMED principles being used. Okay. For micro, small, and medium enterprises, they may not be able to afford the high quality upstream quality assurance systems of organizations. For them, it could still be downstream quality control to a large extent. And therefore, dear friends, when we talk of a global manufacturing hub, the quality of the parts or components, it's a huge industry, the MSME industry in our country, which supplies to these large manufacturing units, automobile industries, okay, and others, they supply. And these ancillaries, they have to follow certain quality principles so that they assure the quality before the component moves out from their factory premises. They can use 7 simple tools of quality. There are 7 simple tools of quality which are called stratification, histogram, Pareto chart, X-bar-R chart, scatter diagram, okay, and the cause and effect diagram, Ishikawa diagram we call that, X-bar-R chart. These are 7 simple tools. They must use them. But right now, if you ask me, in the year 2020, maybe about 30% of these MSMEs have some form of quality control. 70% of the MSMEs just inspect and test using metrology tools, physically, individually. They don't use statistical process control or statistical quality control techniques, which is a must for them now. Analysis of variance, ANOVA means. These are kinds of techniques MSMEs must use, and most of the MSMEs require training in these areas to change their mindset for quality manufacture. Otherwise, the large manufacturing units themselves will reject the supplies of these MSMEs. Just to give you an idea, in an average manufacturing unit in our country, usually the reworks and rejections would be of the order of 25 to 30% of your total production in terms of value. 25 to 30%. And if you can save that, all that is your profitability. To bring down from 25%, 30% to even 10 to 15% requires Herculean effort in terms of using these kinds of tools. That is the my passion for quality actually, therefore, propelled me to take this session just so that, most of us are aware of what quality means when we talk of world class. This is one such tool called DMAIC methodology, used in all Six Sigma process, Six Sigma techniques that organizations use. DMAIC is the Six Sigma methodology to conduct root cause analysis whenever a defect is noticed. Define, measure, analyze, improve, and control. The first letters of these stages of a DMAIC process is, therefore it's called DMAIC. It's a methodology. This methodology involves a high degree of process rigor, dear friends. And talking about process rigor, what I heard from my CEO, earlier CEO in Tata Consultancy Services, rings in my ears even today. He was the one who told me long back when I was in TCS, about 10-15 years back. He's currently the chairman for the Tata Group of Companies, Mr. N. Chandrasekharan. I was fortunate to work under him when we were working for GE, where Six Sigma tools were used. And he told me, when we go back, Suri, to India, start implementing all these practices in your own offshore software development area. He told me, please ensure that the process rigor is maintained. This DMAIC methodology totally talks about process rigor to ensure your process is correct so that you have defect-free production. I talked to you about Pokayoke. It's pronounced Pokayoke. Yokeru means avoid, Poka means mistakes. It's a coined in Japan during the 1960s. It's a part of the Toyota production system. And dear friends, let me tell you, even today, more Toyotas and Hondas you will see on American roads than General Motor and Ford or Ford cars. The reason? The quality and reliability of Toyota and Honda in their manufacture. It speaks volumes of their quality. And they follow these kinds of practices. This is a Japanese word. I'm just giving a brief about that so that you have an idea. A mistake, deviation from what is correct, right, or true. Any deviation from the specification is called a mistake or error or a defect. How to prevent error? Old way, scold people, retrain them, tell them to be more careful. New way, training and motivation. Easy way to do a job. That is the new way. The potential for human error can be dramatically reduced using Pokayoke. How do you do that? You go to the root causes. What causes defects? Errors lead to defects. Poor procedures or standards. Is it the machine? Is it a non-conforming raw material? Is it a worn-out tool? Or is it a human error because lack of sufficient knowledge or skill or training? All this will have to be probed. Okay. In Pokayoke experiments, they take up a proper case where defects are occurring, which they check out that defect item and do a complete reverse engineering of how the defect would have occurred. That is called Pokayoke. So this is the process they go. Production, an error is about to occur, control or shut off. This is what is going to happen. This is happening currently across the globe. Machines themselves predict that something is going wrong and they give you an alarm. An error is about to occur. Control or shut down. Type Pokayoke. Prevent the error from occurring. The Pokayoke process will immediately kick off. Or you detect, you either predict, prevent it, or you detect an error has occurred, warning or attention, type Pokayoke, and that Pokayoke experimentation software runs through it, does the diagnosis, and comes up with what is the root cause for the defect that has been detected. All done by machines. No human involvement, and that is the kind of machine intelligence, machine learning that is currently happening using artificial intelligence. What is SMED? I'm just going to take 2 or 3 more minutes. Dr. Swamy, is that okay?
Sir, absolutely fine, sir.
Thank you. What is SMED? I told you earlier, it means single minute exchange of dice. The acronym for that is SMED. Developed by Shigo Shingo. This is again a Japanese manufacturing designer. A system designed to radically reduce the amount of time to perform a changeover or setup. I'm just giving you here an example. On the left-hand side, you see the tall bar. That was the total setup time that was occurring for a particular case. So they take that as a case study, how to reduce the setup time, say by at least 50% in that. So what they do is they first segregate internal and external elements that are part of that setup of the process. A process has setup and then the processing happens. So the setup part they are analyzing. So in stage 1 they have done that. They reduced from 120 minutes to 80 minutes. So the internal setup time was 80 minutes. External setup time totally they have avoided. From that internal setup time, another SMED analysis was done in a stage 2, convert some internal elements or parts to those of external elements where it is ready-made. Instead of manufacturing it, buy it. It's like make or buy kind of a decision you take for certain of the elements. So you reduce the setup time to 40 minutes. Reduce times of residual internal elements through experimentation, through continuous improvements, through Kaizen and others. And finally, in one particular, it's a real case that they are talking about, it was reduced to 7 minutes. That is about SMED analysis. In conclusion, quality must be at the heart of all processes, whether it's a manufacturing process or whether it is a service delivery process. A do it right first time attitude and every time. It's not just saying it. Designing such quality management systems within the organization and implementing them and complete management support for implementing them is an absolute must. High process rigor is called for, discipline, focus, and attention in all processes because the process determines the product quality. This, particularly in the context of MSMEs, I'm talking about because most MSMEs in India, they adopt shortcuts. Because their objective mainly is to reduce the cost, their own direct labor, material cost, they would like to reduce. But in the process, you may incur the cost of quality if something gets reworked or rejected. And currently it is the tune of 25 to 30%. Training and skill upgradation on cutting edge technologies. Customers everywhere are highly demanding, discerning in terms of quality, price, and timeliness. In all, they want the best. And that's a customer demand. And the customer is the king, he is the God. You can't say no. And therefore, quality becomes an imperative. To become a global manufacturing hub, your products and services must be best in class. In that industry category, those products and services must be best in class. There are some best in class manufacturers in India who are certified best in class. One example, Sundaram Fasteners in Chennai. Their fasteners are world class. Most of the automobile manufacturers everywhere in the world, they place orders on Sundaram Fasteners. I'm just giving you one example. There are such Indian companies. And Sundaram Fasteners have implemented such a nice quality management system throughout their entire organization. I have been witness to that. I have been to Sundaram Fasteners. It's a real treat to watch. Thank you, friends. Through this forum, Dr. Swamy, what I would like to, how to contribute to this, I'm just thinking loudly with you. From our forum, if there are individuals who are assisting MSMEs anywhere in the country, on various aspects, I would like to be a part of that to help, to help them in establishing adequate quality systems which will not cost the organization a lot, but which will definitely improve their quality and reduce their reworks and defects. As a quality consultant, I would like to volunteer myself to do any of this. I'm well versed with some of these tools and techniques, so I can help anybody, and mostly the MSMEs who hardly use any of these tools.